Hello, I'm Colin Summerall. I'm a paleontologist and geologist in the Department of Earth, Planetary, and Environmental Sciences at the University of Tennessee. I'm often brought specimens of rocks and fossils in by the public and asked, what do I have? And one of the most common things that people bring me, and what unfortunately turns out to be not what they expected, are what we call chert nodules. So here I am in a park called Milton Hill Park. It's in northwest Knox County, and we're going to look for a moment at the rock behind me here. It's called the Copper Ridge Dolomite, and this is where chert comes from. In fact, all carbonate units around Knox County, our limestones and our dolomites, are full of chert. So let's go have a look and see what we can see in this beautiful little outcrop. As we walk around, we see lots of limestones, and then over here we see what all the excitement is about. Things like this are chert nodules, and as you can see when you look at them very closely with a very cursory glance, you can see why people think this might be a dinosaur bone. It kind of looks like bone, but in fact this rock is 2.5 times older than the origination of dinosaurs as a group of animals. This rock is nearly 500 million years old. And anytime you have these carbonate units around Knoxville, you see these same sorts of things. Now what happens, let's see if I can find one. Oh, here's a good one. This is a chert nodule that's completely weathered out. And you can see it has all sorts of weird and bizarre morphologies on it. Sometimes these things are almost completely spherical and people mistake them for eggs. But again, these are just chert nodules. Now what's happening is they're forming inside these pieces of limestone. And limestone weathers very easily with rainwater. Oh wow, a geocache. Anyway, limestone weathers really easily in rainwater, and as it rains, you will get these nodules just weathering out, as you see here. And so when you get to areas like I'll show you in a moment on the other side of this hill, the ground is literally littered with these pieces of rock. Now if we walk up towards the top here, gotta watch out for all the mayaples and things, we can see some actual dissolution taking place. So here is a rock with some very small chert nodules in it, and you can see that these areas sticking out in high relief are high in silica. And so, it's really good on this side. So these are the chert nodules weathering out. And if you look at this rock right here, you can see dissolution features of what we call karst. So as this rock weathers away because of rainwater and groundwater running over it, this rock dissolves, leaving behind a residue of this chert. Now this trail I know is littered with chert nodules, so let's go have a look. Kind of windy, that's the forest for you. But here's that trail, and as you can see, we start looking around, we got some chert here. All these pieces here are chert. Nice little piece. And these pieces are very angular because the rocks here are very fractured. And so because of the building of the Appalachian Mountains and so on, we get all these fractures running through the rocks. So what originally were round nodules are turned into little angular bits. But if we're lucky, we should be able to find some more or less nearly spherical, oval, egg-shaped pieces. Here's another one down here. You can see it. Oh, here we go. Here's actually 2 of them. So this thing here, very round, but this is a chert nodule. It's not an egg. You can see right here, this little edge is what often gets people excited thinking they found an eggshell, but in fact that's just the edge of the chert nodule. Here's another round one. This one's a little lumpy, and I've had people say, well, that's the embryo, but those are just little nucleation sites. These nodules form by building layer upon layer upon layer upon each other. And then because of that, they tend to form these shapes. So why don't we take one of these back with us and actually analyze it the way we would as a geologist. So in the lab, we use the most important tool of all geology, soapy water and an old toothbrush. And these are the rocks that we picked up. So here is one of the pieces of chert. This is the one that sort of looks lumpy, but egg-shaped. This is another one that's egg-shaped. And I brought this one along from my backyard, which is just an interesting oolitic limestone that's been replaced by chert. So let's saw these puppies in half. See what's inside. Okay, I got on my eye protection, my ear protection, and here's the water. And here goes the saw. Watch your ears. Okay, so here's the larger specimen cut in half, and you can see on the inside that we're seeing nothing but morphologies that are related to chert formation and maybe a little hint of stromatolitic, that is microbial mats that were present in the original rock. And here's that smaller specimen, and as you can see, we've cut it in half, and if you zoom in, you can see little coated grains which are indicative of a marine carbonate environment. So again, this is a sedimentary rock, it is not an egg. So what does real dinosaur bone look like? Well, it looks like bone. We have this cortical layer on the outside, we see right here. On the inside, we have the spongy material. So it really just, it looks exactly like what you would expect, and very, very much different from what the chert nodule looks like on the inside. Also, this color, while not diagnostic, is pretty typical for dinosaur bone. I mean, I've seen it white, I've seen it various shades, but this sort of dark brownish, rusty color is pretty common. So this is a piece of dinosaur eggshell, and as you can see, it looks very different from, again, our chert nodules. The outside surface has a beaded texture. It has these vertical lines sort of running along it, showing the crystal growth within it. And it very much just looks like a piece of shell, and very different from what we saw in our chert nodule. Well, I hope you learned something about chert today. And I also want to address something that's really important, and that's the disappointment people often feel when I tell them it's a chert nodule. Chert is the raw material from which stone knives, arrowheads, and things like that are made up. It's one of the earliest human technologies. And so, in a way, this particular rock has more influence on the development of human culture than any dinosaur bone or egg ever has or ever will.